Hello everyone, so I'm going to show you how to use this virtual lab experience, and I'm going to help you collect the first couple data points for your lab. So you may want to have your Google Doc open as we go through this so you can get started now. So the first thing we're going to do is go to the stock room, which is on the left-hand side of the lab window. And if we scroll down to the bottom, we're going to see that we can get 100 milliliters of distilled water. So let's go ahead and grab that. Once we grab that water, it adds it to our workbench, which is where we're going to be able to manipulate it. Now, it has some information that we get about the volume, some stuff that we're not going to worry about. What we care mostly about is temperature and the species that are currently in the water other than the water. So right now we see there's nothing in the water other than water, and we see that the temperature is 25 degrees Celsius, which is room temperature. So we're going to go and two-finger click or right-click to get the thermal properties of the water, and we're going to manipulate this water and lower the temperature down to 0 degrees Celsius. Now there's going to be an important thing that I want you to note, right? Once I click OK, we see that the temperature slowly comes back up to room temperature. That's because it's going to pretend like you're actually in a lab experience here, right? So we don't want that to happen for this lab. Maybe in future labs we will. So what we're going to do is we're actually going to select this box that says insulated from surroundings, right? And now what that does is that prevents any heat from the surroundings from warming up our water. So it'll remain at 0 degrees Celsius for as long as we want it to be. Now, I'm going to go back to the stock room and I'm going to select the chemical that we're going to start with, potassium chloride. And if you look here, I get a container of potassium chloride that has 156.576 grams of potassium chloride in, more than we need, right? So what I'm going to do is I'm going to take this and now I'm going to add this potassium chloride to the distilled water. But before you do that, we have to lower the temperature of the potassium chloride down. This will act like a normal lab experience. And if I were to add the potassium chloride at 25 degrees Celsius into my water at 0 degrees Celsius, we would get heat transfer. So we don't want that to happen. So I'm going to go ahead and I'm going to take the thermal properties, I'm going to insulate it as well, and I'm going to lower this down to 0 degrees Celsius as well. So now I have my potassium chloride at 0 degrees Celsius and my water at 0 degrees Celsius. I'm going to combine the two by just grabbing the bottle of potassium chloride, dragging it over to the Erlenmeyer flask. And once I do that, it gives me an option of how much I want to add. I'm going to go ahead and add 100 grams, 100.0 grams of potassium chloride to the water mixture, right? Now it gives me a confirmation. It says, hey, 100 grams has been transferred. Good, awesome. Now if you look afterwards, there's only 56 grams of potassium chloride left because I had 156 to start. Now if I look in my Erlenmeyer flask, however, I see, okay, 100 milliliters of distilled water, it's what it's called. I'm going to rename it because it's no longer that. It is now a potassium chloride aqueous solution. Potassium chloride aqueous solution. But if you look here, it says there's 71.1349 grams of potassium chloride in there. But why is that? Because we know that we had 100 grams of potassium chloride that we added, right? So here's the deal. When you see this view, it is not showing you the total amount of that species in that solution. It's showing you how much solid potassium chloride is currently in your beaker, right? Now that's an important difference because what happens is when you add potassium chloride, a certain portion of it dissolves and becomes aqueous, but not all of it, right? Unless you are below the saturation point. And so when we added the 100 grams of potassium chloride, we can see that about 28.87 grams dissolved, leaving us with our 71.13 grams remaining as a solid, right? So when you add your first data point, which you should do right now, for the temperature of 0 degrees Celsius, you should add the amount of solid potassium chloride remaining in your flask, and then we will calculate how much that means must have dissolved, right? So as you go through, every time you add a value, you're going to add the grams of that species that remain solid in a flask, therefore have not dissolved. And then we will calculate how much have actually dissolved. Now, so that's your first value for 0 degrees Celsius, but let's warm it up, right? So we can go to our second value of 10 degrees Celsius. So to do that, we're going to go back to the stock room. We're going to select a tool and we're going to select a Bunsen burner. Now this brings the Bunsen burner into our setup. And so what I'm going to do is I'm going to lower the heat on this Bunsen burner a little bit. I'll lower it down to like 0.2 kilojoules per second. That's how much heat it'll add in. Now, just like when you add the salt, if I drag this Bunsen burner over to the Erlenmeyer flask, it'll begin to heat it up, as we can see here. I'm going to let that continue to heat until it gets to about 10 degrees Celsius. Now, I want to get as close to 10 degrees Celsius as possible, right? But I don't need it to be exactly 10 degrees Celsius, right? I want to simulate a little bit of the lab experience that's going on. So as we're getting close, I'm going to pull it off. Boop. There you go. So I pulled it off at 9.990 degrees Celsius. So when I go to my data table, I will record 9.99 degrees Celsius instead of 10, because that's the actual temperature of this data point, right? And then I will record 68.40 grams of solid potassium chloride that remain in the flask. You'll notice that that went down, meaning more has dissolved. And then I will calculate how much has dissolved, right? Now, if I want to go and get to the next data point of 20 degrees Celsius, I just bring the Bunsen burner back over and it starts to go up. You'll notice that the solid mass of potassium chloride as this heats up is going down because more of it is getting dissolved. Right, so we're going to let it continue on. We're at 15 degrees Celsius. We have 5 more to go, right? This is going down even more as it's becoming more and more soluble as the solution heats up. And we get to 20 degrees Celsius. I'm going to pull it off. There, so 19.96 degrees Celsius would be my recording value for the 20 degrees Celsius. And I see that has 65.63 grams of solid potassium chloride, which means I can calculate how much has dissolved, right? So continue on with the remaining values all the way up to 100 degrees Celsius. And really, the rest of the lab should be fairly simple because it's just going to be using those same steps. All right, good luck.